In question one, we have that the sum of the first 9 terms of an arithmetic progression is 117. The sum of the next 4 terms is 91. So we can say that the sum of the first 9 terms is 117, and the sum of the first 13 terms would be 117 plus 91. We know that the formula for the sum of an AP is n upon 2 bracket 2a plus n minus 1 times d, which is the common difference. So the first thing we have to do is that for the first 9 terms, the sum is 117. So we write 117 is equals to n is 9 upon 2 bracket 2a plus n minus 1 will become 8 times d, which is 8d. Simplifying this equation, we'll multiply 2 by 117, we'll get 234 is equals to 9 times 2a plus 8d. 234 divided by 9 is 26. So we can say 2a plus 8d is equals to 26. Dividing the whole equation by 2 to make it simpler, we can write it as a plus 4d is equals to 13. So we have a first equation, which is a plus 4d is equals to 13. For the second equation, we know that the sum of the first 13 terms is 117 plus 91, which is 208. So we can say 208 is equals to 13 upon 2 bracket 2a plus 13 minus 1, 12d. 2 times 208 will become 416 is equals to 13 times 2a plus 12d. 416 divided by 13 is 32. So we'll say 32 is equals to 2a plus 12d. Dividing the whole equation by 2, we'll get a plus 6d is equals to 16. Now we have to solve the two equations simultaneously. So a plus 4d is equals to 13. A plus 6d is equals to 16. So we can change the sign of the second equation. A and a will cancel. 4d minus 6d is minus 2d. 13 minus 16 is minus 3. So d will become 3 upon 2. For a, we can use the first equation, which is a plus 4d. We know that the value of d is 3 upon 2 is equals to 13. 2 ones are 2 twos are, so we get a plus 6 is equals to 13. And a is equals to 13 minus 6, which is 7. In this question, the coefficient of 1 upon x is 74. So first we need to know what is the coefficient of 1 upon x in the first expression and in the second expression. We know that the expansion formula is NCR a power n minus r b to the power r. Now we can guess what the value of r could be that will give us the coefficient as 1 upon x, or we can use the method where we can say 5CR. We are trying to find the value of r. The variable a is x to the power 5 minus r, and the variable b is x to the power minus 1 to the power r, and we need the coefficient of 1 upon x, so we can say we need x to the power minus 1. Simplifying, we get 5 minus r is equals to minus 1. So minus 2r is equals to minus 6. So we can say that r is equals to 3. So using 5c3, kx to the power 5 minus 3, which is 2, and 1 upon x to the power 3. So 5c3 is 10. We get 10k squared x squared into 1 upon x cubed. Simplifying, we know that the coefficient of 1 upon x in the first expression is 10k squared. For the second expression, again, we can use this method, or we can directly assume that using 8c1, we will get b to the power 1, which is 2 upon x. So we'll get 8c1 b to the power, which is b is minus 2 upon x to the power 1. This will become 8c1 is 8. So 8 times minus 2 will be minus 16 upon x. So we know that the coefficient of 1 upon x in both the expressions In one of the expressions 10k squared, and in the other expression it is minus 16. So we can say 10k squared minus 16 is equals to 74. Simplifying this, we get 10k squared is equals to 74 plus 16, which is 90. So k squared is equals to 9. When we square root the value of 9, we get k is equals to plus minus 3. In the question, it says find the value of the positive constant k. So it means we'll just take the value of k is equals to 3. In question 3, we have that in each year, the selling price of a diamond necklace increases by 5%. So whenever an amount is increasing by a particular percentage, we know it is a geometric progression. So we can write it as a geometric progression where the common ratio would be, because it is increasing by 105, so the second term would be 105 if the first term is 100%, which will become 1.05. The selling price of the necklace in the year 2000 was $36,000. We have to write an expression for the necklace n years later. So we can say that A is equals to $36,000. Nth term of a geometric progression is given by AR to the power n minus 1. So we have A is equals to 36,000 times 1.05 to the power n minus 1. So this is the expression for the selling price of the necklace n years later. To find the selling price in 2008, we know that in 2008, so the value of n will be 9, because if we start from 2000, that is the first year, 2001 will be the second year, so 2008 will be the ninth year. So substituting n is equals to 9 into the equation, we have nth term is equals to 36,000 into 1.05 to the power 9 minus 1. Using our calculator to find this value, we get $53,188. Because in the exam, we have to give our answer to 3 significant figures, so the final answer will become $53,200. In part B, we have to find the total amount of money in the 10-year period starting in the year 2000. So for the sum, we know that the formula is A into R power n minus 1 to the power R power n minus 1 to the power n upon, sorry, there's no power n over here, upon R minus 1. The first term was $36,000. R is 1.05 to the power 10 minus 1 upon 1.05 minus 1. Using our calculator, the sum of the first 10 terms would be 452,804. Giving our answer to 3 significant figures, we'll have 453,000. So this will be the sum in a 10-year period. In question 4, we have a graph of y is equals to f of x, where f of x is 3 upon 2 cos 2x plus half. Now this plus half represents that the graph has moved half units upwards, and the 3 upon 2 is the amplitude. So the maximum point would be half plus 3 upon 2, and the lowest point would be 3 upon 2. So for the maximum value, we will have half plus 3 upon 2, which is 4 upon 2, which is equals to 2. And the minimum value would be half minus 3 upon 2, which is minus 2 upon 2, which is minus 1. So we can say that the range of f of x is greater than equals to minus 1 and less than equals to positive 2. In the next part, we have a function g that is equals to f of x plus k, where k is a positive constant. The x-axis is a tangent to the curve. Now, if the x-axis is a tangent to the curve, we know that the graph has basically moved upwards and is somewhat like this, which means that this point has moved 1 unit upwards, as the lowest point was minus 1. So we can say that k is equals to positive 1. As the movement was only 1 unit in the y direction, we can say that the transformation is a translation. As in translation, we either move in the x or the y axis. And in this case, we only moved in the y-axis, so we can say it was a translation of 0 and 1. In part C, we have to state the equation of a curve which is the reflection of y is equals to f of x in the x-axis. Now we know that f of x is equals to 3 upon 2 cos 2x plus half. When it is a reflection in the x-axis, the whole function is multiplied by -1, as the part below the x-axis is reflected upwards and the part above the x-axis is reflected downwards in the x-axis. We multiply the whole equation by -1, and the equation would be written as -3 upon 2 cos 2x minus 1 upon 2. In question 5, we have equation of a line y is equals to mx plus c and the equation of a curve xy equals to 16. Given that the line is a tangent to the curve, we have to express m in terms of c. Now, when it says it is a tangent, it means we only have one point of intersection. And one point of intersection basically represents that the discriminant, which is b squared minus 4ac, is equals to 0. So now equating the two equations, we have the equation of the curve, which is y is equals to 16 upon x, and the equation of the line, which is y is equals to mx plus c. Equating them, we get 16 upon x is equals to mx plus c. Simplifying this, we get mx squared plus cx minus 16 is equals to 0. Now we know that b squared minus 4ac equals to 0. So in this case, b is c over here minus 4. In place of a, we will put m, and in place of c, we'll put minus 16 equals to 0. So we get c squared plus 64m is equals to 0. Representing m in terms of c, we'll get m is equals to minus c squared upon 64. In part B, we have that the value of m is equals to minus 4. Find the set of values of c for which the line intersects the curve at two distinct points. Now, in this case, we know that b squared minus 4ac should be greater than 0 if it is intersecting at two distinct points. So m is equals to minus 4. We can say minus 4 is equals to minus c squared upon 64. The negative signs cancel out. So we have c squared is equals to 256, or c is equals to plus minus 16. Now to give the correct inequality signs, we can make c minus 16 and c positive 16. Now as b squared minus 4 is greater than 0, we need the values of c which are above the x-axis. So these values, basically, if we go further back from minus 16 and forward from positive 16, we'll have b squared minus 4ac as greater than 0. So we can say that c is greater than 16 and c is less than minus 16. In question 6, we have two functions f of x, which is half x minus a, and g of x, which is 3x plus b. It says that g of 2 is equals to 10. This means that in the function g, which is 3x plus b, we will write in place of x 3x plus b again, plus b is equals to 10. In place of x, we have to write 2, so we get 3 times 2, which is 6, plus b is equals to 10. We get 18 plus 3b plus b is equals to 10. So we have 4b is equals to minus 8, 10 minus 18, and b is equals to minus 8 divided by 4, which is minus 2. And the second part, we have f inverse of 2 is equals to 14. So f inverse of 2, we first have to find f inverse. We know that the function f is half x minus a. So in place of f of x, we can first write y. Replacing x with y and y with x, we get x is equals to half y minus a. So y is equals to x plus a. So half y is x plus a. So y is equals to x plus a times 2. So we now know that f inverse of x is 2 times of x plus a. Now it is given that f inverse of 2 is equals to 14. So we can write 14 is equals to 2 times, so this is a, 2 plus a. We get 4 plus 2a is equals to 14. So a is equals 2a is equals to 14 minus 4, which is 10. So a is equals to 5. Now in the second part, we have to find the expression for g f of x using the values of a and b. We know that f of x is equals to half x minus a, and the value of a is 5. And g of x is 3x plus b, so this will become 3x minus 2. To find g f of x in the function g, we will replace x with the function f. So g f of x is equals to 3 times half x minus 5 minus 2. This will become 3 upon 2x minus 15 minus 2. Simplifying this, we get g f of x is equals to 3 upon 2x minus 17. In question 7, we have to prove the identity 1 plus sine upon cos plus cos upon 1 plus sine is equal to 2 upon cos. So the easiest way to prove identity is just to apply basic algebra. We can start off by taking the LCM, which is cos and 1 plus sine. So multiplying 1 plus sine, so this will multiply by 1 plus sine, and cos will multiply by cos, so we'll get cos squared. Expanding the numerator, we have 1 plus sine plus sine squared plus cos squared upon cos into 1 plus sine. So we have 1 plus 2 sine plus sine squared plus cos squared divided by cos into 1 plus sine. Now we know that sine squared plus cos squared is 1, and 1 plus 1 will become 2. So we have 2 plus 2 sine upon cos into 1 plus sine. Taking 2 common in the numerator, we have 2 into 1 plus sine upon cos into 1 plus sine. So cancelling 1 plus sine and 1 plus sine, we have 2 upon cos theta. In the second part, we have hence solve the equation 1 plus sine upon cos plus cos upon 1 plus sine is equal to 3 upon sine theta. Now we know that this identity, this is the same as 2 upon cos theta as proved in the first part. So we can write 2 upon cos is equals to 3 upon sine. So bringing sine on the left hand side, we'll get sine upon cos is equals to 3 upon 2. Sine upon cos is tan, so we get tan theta is equals to 3 upon 2. And the theta is from 0 till 2 pi, so our calculator must be in radian form. Taking tan inverse of 3 upon 2, we have theta is equal, the basic angle is equals to 0.983. We know that tan is positive in the first and the third quadrant. So we'll have 0.983 over here in the first quadrant and 0.983 with the x-axis in the third quadrant. So theta will be 0.983 as we measure our angle from the positive x-axis anti-clockwise, and the second angle would be pi plus 0.983. So we'll write pi plus 0.983. So theta will be 0.983 and 4.12. So in question 8, we have a semicircle with diameter AC and radius 6. The length of the arc AB is 15. We have to find the perimeter of the shaded region BXC. So the region BXC is basically defined by the arc BC plus the length of BX plus the length of xc. So first we can find this angle. Let's say this is theta. So we know that the arc length is given by S is equals to r theta. S is 15 and the radius is 6. So theta would be 15 upon 6, which is 2.5 radians. Now this is 2.5 radians. This would be pi minus 2.5, which is the angle BOX will be pi minus 2.5. To find the length of BX, we know that OB is also 6 as this is the radius. So we can write sine of pi minus 2.5 is equals to opposite, which is BX upon 6. So BX will be 6 times sine of pi minus 2.5. We have to make sure that our calculator is in radian mode. So Bx is equals to 3.59 centimeters. The arc BC, the arc length of BC will be r theta. So we know that the radius is 6 and the angle is pi minus 2.5. So the arc length will be 3.850 centimeters. And finally, to find the length of OC, we can first find the length of OX. So using cos of pi minus 2.5, we can write OX, which is adjacent upon hypotenuse, which is 6. So the length of OX will be 4.807. So the length of XC would be 6 minus 4.807, which is equals to 1.193. 1.193. So we have the length of XC, we have the length of BX, and we have the arc length, which is 3.850. Adding these three values, we'll get the perimeter of the shaded region. So the perimeter would be 3.85 plus 3.59 plus 1.193 centimeters, which is equals to 8.63 centimeters. In question 9, we have the equation of a curve y is equals to 3 minus 2x whole cube plus 24x. We have to find dy dx and d square y dx square, which is a double derivative. So we know that for dy dx, we'll multiply the 3 by the coefficient. This will become 3 into 3 minus 2x whole squared and multiplied by minus 2 plus 24x. The derivative of 24x would be 24. So we will get minus 6 into 3 minus 2x whole squared plus 24. For the double derivative, we will differentiate our dy dx. So we'll get minus 12 into 3 minus 2x to the power 1 multiplied by minus 2, and this 24 will become a 0. So we'll get 24 times 3 minus 2x, or 72 minus 48x. In part B, we have to find the coordinates of each of the stationary points on the curve. For stationary point, we know that dy dx is equals to 0. And we know that the dy dx is minus 6 into 3 minus 2x whole square plus 24. So minus 6 into 3 minus 2x whole squared plus 24 is equals to 0. Taking 24 on the other side, we get minus 6 into 3 minus 2x whole squared is equals to minus 24. Taking minus 6 on the other side, we will have 3 minus 2x whole squared is equals to positive 4. Taking square root on both the sides, we have 3 minus 2x is equals to plus minus 2. So we have minus 2x is equals to 2 minus 3 minus 2x is equals to minus 1. So x is equals to positive 1 upon 2. And the second value of x would be minus 2x is equals to minus 2 minus 3, which will be minus 5 upon minus 2, which is positive 5 upon 2. Substituting 1 upon 2 into the original equation, y is equals to 3 minus 2x whole cube plus 24x. We will get y is equals to 20, and substituting 5 upon 2 into the original equation, we'll get y is equals to 52. So the coordinates will be 1 upon 2 comma 20 and 5 upon 2 comma 52. In part C, we have to determine the nature of each stationary point. So for each stationary point, the nature that if the double derivative is positive, it is a minimum point. We know that the double derivative is 72 minus 48x. Substituting half into the equation, we get 72 minus 48 into half. 72 minus 24 is 48. So we know that 1 half and 20 is a minimum point, as this is greater than 0. Substituting 5 upon 2 into 72 minus 48x, we get 72 minus 48 into 5 upon 2. So 72 minus 120 will be a negative, which is less than 0. So we can say that 5 upon 2 comma 52 will be a maximum point. In question 10, we have coordinates of points A and B. We have to find the equation of a circle C for which AB is the diameter. So making a circle, A and B is the diameter. So we can say that the midpoint of AB would be the center of the circle and the half of the length of AB would be the radius. We know that the equation of a circle is given by x minus a whole squared plus y minus b whole squared is equals to r squared, where a comma b are the coordinates of the center and r is the radius. So first, finding the distance AB, we have y2 minus y1, which will become 4 plus 2 whole squared, plus 7 minus minus 1, which will become 7 plus 1 whole squared. This will become 6 square, which is 36, plus 8 square, which is 64. So the length of AB is 10. So the diameter is 10, which means that the radius is 5. For the center, we need to find the midpoint of AB. So we can use x1 plus x2, which is minus 1 plus 7 upon 2, comma minus 2 plus 4 upon 2. So the midpoint would be 6 upon 2, which is 3, comma minus 2 plus 4, 2. So the coordinates of the midpoint or the center of the circle is 3, comma 2. Substituting this into the equation, we get x minus 3 whole squared plus y minus 2 whole squared is equals to r squared, which is 25. So this is the equation of the circle C. In part B, we have to find the equation of the tangent T to the circle at the point B. Now, if you make the circle C again, and this is the point B, we have to find the equation of the tangent at point B. For the tangent, we need the gradient, and for the equation of any line, we have to find the gradient and a point. So we know that point B, which is 7, 4, is a point on the tangent. For the gradient, we know that the tangent is perpendicular to the radius or the diameter. So first we can find the gradient of AB, which will be y2 minus y1. So we can say this will become 4 minus minus 2, 6. So this will become 4 minus minus 2 upon 7 minus minus 1. So the gradient of line AB will be 6 upon 8, which is 3 upon 4. the gradient of the tangent would be the negative reciprocal as it is perpendicular. So this will become minus 4 upon 3. We know that the equation of a line is given by y minus y1 is equals to m into x minus x1. So y minus, the value of y is 4. The gradient is minus 4 upon 3 into x minus 7. Simplifying this, we get 3y minus 12 is equals to minus 4x plus 28, which can be written as 3y plus 4x is equals to 28 plus 12, which is 40. In part C, we have to find the equation of a circle which is a reflection of the circle C in the line T. We know that the line T is a tangent. Let's say this is circle C and this is the tangent. And we have to find the equation of a circle which is a reflection in the line T. So we know that this point B is 7, 4. We know that this is the center, which is the center of the circle was 3, 2. Now we know that the radius of this circle would also be 5. We just need to know the center of this other circle, which is a reflection of the circle C. Now we know that B is the midpoint from the center of the first circle to the center of the second circle. So we can say that 7, 4, which is the midpoint, and let's say the center of this circle is x, y, is basically is equals to x plus 3 upon 2, comma 2 plus y upon 2. So 7 is equals to x plus 3 upon 2. X is equals to 11 because 7 times 2, 14. 14 minus 3 is 11. And 4 is equals to 2 plus y upon 2. So the y value would be 8 minus 2, which is 6. So the equation of the reflected circle would be x minus 11 whole squared plus y minus 6 whole squared is equals to r squared, and the radius will be the same as it is a reflection. So this will be r squared, which is 25. In question 11, we have a curve which is y is equals to 8 upon x plus 2 and the line 2y plus x equals to 8 intersecting at points A and B. The point C lies on the curve and the tangent to the curve at C is parallel to AB. So we know that if we make a tangent to the curve at C, it is parallel to AB, which means that the gradient of AB and the tangent to C are equal. We have to find the coordinates of A, B, and C. To find the coordinates of A and B, we can solve the equation of the curve, which is 8 upon x plus 2, and the equation of the line, which is y is equals to 8 minus x upon 2. We can solve them simultaneously. So cross multiplying, we'll get x plus 2 multiplied by 8 minus x is equals to 16. Expanding this, we get 16 minus x squared plus 16. So this will be x into 8, which is 8x minus x squared plus 16 minus 2x is equals to positive 16. 16 and 16 will cancel out. We will have 8x minus 2x, which is equal to 6x minus x squared is equal to 0. Now there is one common mistake that students make. They take the 6x or the x squared on the other side and cancel out the values of x, and they give x equals to 6. Now in this case, we know that we already have two values of x, so students can avoid this mistake, but if it is not mentioned, they only give one solution, which results in a loss of marks. To avoid this, we always take x common and we write 6 minus x equals to 0. So we have two values of x, which is x equals to 0 and x equals to positive 6. Substituting these values into the equation of the curve or the line, we can get the value of y. So substituting 0 in the equation of the curve, 8 upon 0 plus 2, we get y equals to 4. So these are the coordinates of A, as we know that the x coordinate of A would be 0 as it is on the y-axis. And substituting x equals to 6, not 16, obviously. So this is x equals to 6. Into the equation 8 upon 6 plus 2, we get y equals to 1. These are the coordinates of B. For coordinates of C, we know that the gradient at point C is equal to the gradient of AB. So the gradient of AB is equals to y2 minus y1. So we can write 1 minus 4 upon x2 minus x1. So we know that the gradient of AB is minus 3 upon 6 or minus 1 upon 2. The gradient of the curve at point C is dy dx. So finding dy dx, we know that the equation of the curve is 8x plus 2 to the power minus 1. Differentiating this, we get minus 8 into x plus 2 to the power minus 2, or minus 8 upon x plus 2 whole squared. Equating this to the gradient of the line AB, we have minus 8 upon x plus 2 whole squared is equals to negative 1 upon 2. The negative signs cancel out, and we have x plus 2 whole squared is equals to 16. Taking square root on both the sides, we have x plus 2 is equals to positive 4. We won't be taking negative 4 as we know that C has a positive x value. So x is equals to 4 minus 2, which is 2. Substituting x equals 2 into the equation of the curve, which is y is equals to 8 upon x plus 2. So we get y is equals to 8 upon 2 plus 2, which is y is equals to 2. So the coordinates of C are 2 and 2. In part B, we have to find the volume generated when the shaded region bounded by the curve is rotated through the x-axis. Now for the volume of the shaded region, we will find the volume under the line and subtract it from the volume under the curve, and this will give us the shaded region. Because the volume under the line would be this whole area, and the volume under the curve would be this part. So subtracting these two volumes, you will get the volume of the shaded region. So first, finding the volume of the line, volume under the line, we have we know that to find the volume, we take pi times square of the function, and we know that the limits are 6 and 0, as the coordinates of B, the x coordinate was 6, and this is the coordinate of A, which is 0. So the equation of the line is 8 minus x upon 2. So we write 8 minus x upon 2 whole squared dx, and taking the limits as 6 and 0. So we have 8 minus x whole squared upon 4. Integrating this, we get 8 minus x to the power 3 divided by 4. So we multiplied by the new power, which is 3, and the derivative of the function 8 minus x, which is minus 1. So we get 8 minus x whole cube upon minus 12. Now we have to substitute the limits, which are 6 and 0. So substituting 6 into the equation, we have 8 minus 6, which is 2 whole cube 8. So we have minus 8 upon 12. And substituting 0 into the equation, we have 8 cube, which is 512 upon minus 12. So we have minus 512 upon 12. So minus 8 plus 512 is 504 divided by 12. We have 42 pi, which is the volume under the line. Now for the volume under the curve, we know that the equation of the curve is 8 upon x plus 2. So 8 upon x plus 2, first we whole squared this, and then we integrate, taking the limits as 6 and 0 again. So this will become 64 into x plus 2 to the power minus 2. The limits are 6 and 0. Now integrating this, we get 64 into x plus 2 to the power minus 1 divided by minus 1. So we have minus 64 upon x plus 2. Now substituting the upper limit, which is 6, we get minus 64 upon 6 plus 2, which is 8. And then substituting 0, we get minus 64 upon 0 plus 2, which is 2. So this will become minus 32. So this will become minus 8 plus 32, which is 24. And as pi was a constant, so this will become 24 pi. So for the volume of the shaded region, we will take the volume under the curve, which was 42 pi, minus the volume under the curve, which is 24 pi. So 42 pi minus 24 pi would become 18 pi, which is the volume of the shaded region.